Have you ever gazed up at a sky so clear and blue, it felt like you could reach out and touch the stars? For pilots, that clarity isn't just about admiring the view, it's about survival. Visibility is the lifeblood of safe aviation. It's the difference between a smooth flight and a potential disaster. When pilots take to the skies, they trust in their training, their aircraft, and crucially, their ability to see and be seen. But when visibility deteriorates, tension rises in the cockpit. The history of aviation, while marked by incredible triumphs, is also etched with tragedies. Many of these accidents stand as stark reminders of the devastating consequences of poor visibility. Controlled flight into terrain, a chilling phrase for a pilot's worst nightmare, has often been linked to situations where pilots, blinded by fog or other obscurations, lose vital visual contact with the ground. Disorientation can grip even the most seasoned pilot when visibility drops. Without clear visual references, the body's internal compass struggles to maintain equilibrium, potentially leading to disastrous consequences. Visibility in its simplest form is about how far we can see. But for pilots, it's far more nuanced. It's about understanding the very air they fly through, recognizing the subtle cues that differentiate a clear day from a potentially hazardous one. It's about knowing the difference between visual meteorological conditions, where the world is crisp and clear, and instrument meteorological conditions, where instruments become the pilot's lifeline. Visibility dictates the rules of the game, determining if an airport is safe for landing or if a flight must be delayed or diverted. Understanding these factors is paramount for any pilot. Visibility. It seems like such a simple concept, doesn't it? We all instinctively know what it means to see clearly or to have our vision obscured, but in the world of aviation, visibility takes on a more precise, almost scientific meaning. Imagine standing on a hilltop, gazing out at the horizon. How far can you see? What's the farthest point at which you can make out a distinct object, like a dark tower against the sky? That, in essence, is visibility. For pilots, understanding the factors that affect atmospheric clarity is crucial for safe navigation. When clarity fades, the culprits of reduced visibility. One of the primary culprits is water, in its various forms. Think of a thick fog bank rolling in from the sea, tiny water droplets suspended in the air, each one scattering and absorbing light, reducing visibility to mere meters. Or picture a torrential downpour, the air thick with heavy raindrops, obscuring the runway ahead. And then there are the solid particles, the tiny but mighty dust, sand, and smoke that can turn a clear sky into a hazy soup. From fog to haze, distinguishing the types of obscuration. When we talk about reduced visibility in aviation, we're not just talking about a general haziness. Fog, mist, and haze, these three words, often used interchangeably in everyday conversation, take on distinct meanings in the world of aviation. Fog, the densest of the three, is defined as a suspension of tiny water droplets in the air that reduces visibility to less than 1 kilometer. Haze, unlike fog and mist, isn't caused by water droplets. Instead, it's the result of tiny solid particles like dust, smoke, or pollutants suspended in the air. The blanket of white understanding fog. Fog, it's a word that evokes images of mystery, of landscapes shrouded in an ethereal white veil. For pilots, fog is anything but romantic. It's a serious meteorological hazard, a dense curtain of water droplets that can bring visibility down to dangerously low levels. Imagine yourself on the flight deck, peering out into a world transformed by fog. The familiar landmarks, the runways, even the wingtips of your own aircraft vanish into this swirling white abyss. Technically speaking, fog is defined as a suspension of water droplets in the air that reduces visibility to less than 1 kilometer. A veil of moisture. Exploring mist. If fog is the heavy curtain that obscures the world, then mist is its lighter, more ethereal cousin. Mist, like fog, is composed of tiny water droplets suspended in the air, but it's less dense, allowing for slightly better visibility. In aviation, mist is defined as a suspension of water droplets that reduces visibility to between 1 and 5 kilometers. While mist doesn't typically pose the same level of hazard as dense fog, it can still reduce visibility significantly, making it crucial for pilots to exercise caution. The dust's hazy grip. Unveiling haze. Haze. Unlike fog and mist, which are caused by water droplets, haze is the result of tiny, solid particles suspended in the air. These particles, often dust, smoke, or pollutants, scatter and absorb sunlight, giving the sky a milky or yellowish appearance. In aviation, haze is defined as any suspension of solid particles in the air that reduces visibility to less than 5 kilometers. Born of the Earth's embrace radiation fog. Imagine a crisp, clear winter morning. The stars have begun to fade and the eastern sky hints at the coming dawn. You step outside and a wave of cold air washes over you. But something's different. The air is thick, heavy with moisture. And then you notice it, a blanket of fog hugging the ground, engulfing the landscape in a soft, white embrace. Radiation fog, as its name suggests, is all about heat, or rather, the lack of it. As the sun dips below the horizon, the Earth begins to cool, radiating its heat into the atmosphere. This cooling effect is most pronounced on clear nights when there are no clouds to trap the escaping heat. The traveler's shroud. Advection fog. While radiation fog is a creature of stillness born from the Earth's gentle cooling, advection fog is a traveler, carried on the wings of the wind. Imagine a warm, moist breeze blowing in from the sea, carrying with it the scent of salt and the promise of adventure. This breeze, laden with moisture, encounters a cold current or a landmass chilled by the night air. As the warm, moist air flows over this colder surface, it too begins to cool. Advection fog, unlike its more stationary cousin, is constantly on the move. It flows, swirls, and shifts with the wind, creating an ever-changing landscape of visibility. From icy breath to misty veil, steaming fog. Steaming fog, also known as Arctic sea smoke, is a spectacle best observed from a safe distance, preferably with a warm cup of cocoa in hand. This ethereal phenomenon occurs when frigid Arctic air flows over relatively warmer water. As the frigid air flows over this warmer water, a remarkable transformation occurs. The water, warmer than the air above it, evaporates, sending plumes of water vapor into the atmosphere. This is Arctic evaporation, where the air is so cold that the water vapor condenses almost instantly, forming tendrils of fog that rise and swirl like smoke from a dragon's nostrils. When fronts collide and visibility fades, unveiling frontal and orographic fog. Frontal fog is associated with weather fronts, those boundaries between air masses of different temperatures and densities. Imagine a warm front advancing, replacing a colder air mass. As the warm, moist air rises over the cooler air, it cools and condenses, forming a blanket of fog along the frontal boundary. This type of fog can be particularly dense and widespread, sometimes stretching for hundreds of miles along the front. Now let's shift our gaze to the majestic realm of mountains, where orographic fog, also known as hill fog, makes its ethereal presence known. Imagine moist air being forced upward as it encounters a mountain range. As this air ascends the slopes, it cools, and if it cools to its dew point, condensation occurs, forming a veil of fog that drapes itself over the peaks and valleys. We've explored the world of fog, mist, and haze, those atmospheric phenomena often associated with reduced visibility. But now, let's turn our attention to a different kind of threat, one that doesn't announce its presence with swirling mists or ethereal veils. I'm talking about the silent blinders, dust and sand particles, those tiny, seemingly insignificant specks that can transform a clear sky into a hazy, potentially dangerous soup. Imagine standing on the edge of a vast desert, the sun beating down from above. The air seems clear, the sky a brilliant blue, but look closer, and you'll notice a subtle haze, a milky veil softening the edges of the distant dunes. That haze, my friends, is the work of countless dust and sand particles, lifted from the ground by the wind and carried aloft into the atmosphere. These particles, often too small to be seen individually with the naked eye, have a remarkable ability to scatter and absorb light. As sunlight passes through this airborne dust and sand, it's deflected in all directions, reducing visibility and creating that characteristic hazy appearance. Dust and sand particles, while a constant presence in arid regions, become a formidable threat when the wind kicks up. Dust storms and sandstorms can transform a clear day into a swirling brownout in minutes. The wind howls, whipping the sand into a frenzy. The air grows thick, the sun disappears, and visibility plummets. This is a dust or sandstorm in full fury. These storms occur when strong winds pass over dry, dusty areas. The wind lifts dust and sand particles high into the atmosphere. Dust and sandstorms are serious meteorological hazards. Reduced visibility can ground aircraft and make road travel treacherous. Inhaled dust can pose serious health risks. For pilots, dust and sandstorms present a unique set of challenges. Imagine yourself at the controls of an aircraft, cruising at altitude, the world below a tapestry of browns and yellows. Suddenly the radio crackles to life, a warning of a dust storm approaching your flight path. Your heart rate might quicken just a tad. Dust and sandstorms, with their rapidly changing conditions and dramatically reduced visibility, demand a pilot's full attention and a healthy dose of respect. The primary concern, of course, is visibility. In a severe dust or sandstorm, visibility can drop to near zero, making it impossible to navigate visually. Pilots must rely on their instruments, their radar, and their training to maintain control of the aircraft and navigate safely through this blinding haze. But visibility is just one piece of the puzzle. Dust and sand particles can also clog engine intakes, reducing engine performance and potentially leading to engine failure. And the abrasive nature of these particles can sandblast windshields, reducing visibility even further and potentially damaging critical aircraft components. Piercing the veil instruments of clarity. We've journeyed through the world of fog, mist, haze, and dust storms, those atmospheric phenomena that can turn a pilot's clear view into a hazy challenge. But how do we measure these obscurations? How do we quantify something as seemingly subjective as visibility? Well, my friends, just as we've developed instruments to measure wind speed, air pressure, and temperature, we've also devised ingenious ways to pierce the veil of obscurity and measure visibility with scientific precision. One such instrument, a marvel of modern meteorology, is the transmissometer. Imagine a beam of light shining like a beacon through the atmosphere. A transmissometer, strategically positioned at one end of a runway or airfield, emits a beam of light towards a receiver located a known distance away. As this beam travels through the air, it encounters those tiny particles that reduce visibility, water droplets, dust, smoke, you name it. These particles absorb and scatter the light, reducing the amount that reaches the receiver on the other side. The transmissometer, like a keen-eyed observer, measures how much light makes it through and calculates the atmospheric visibility based on that measurement. The runway's Guiding Light Runway Visual Range, or RVR. Imagine yourself on the flight deck, preparing to land after a long journey. The weather report mentions reduced visibility. How do you know if it's safe to land? This is where Runway Visual Range, or RVR, comes into play. RVR tells you how far down the runway you can see from the cockpit. It's about seeing runway lights, markings, and crucial visual cues for a safe touchdown. Decoding the language of visibility reports and observations. In aviation, communication is key. Pilots, air traffic controllers, and meteorologists speak a common language filled with acronyms and codes. Visibility reports are crucial, ensuring everyone is on the same page. Meters and TAFs provide standardized visibility information. For example, a meter might state visibility 10 kilometers. This means objects are visible up to 10 kilometers. When visibility drops, reports become more specific. For instance, visibility 2,000 meters variable to 4,000 meters. This indicates fluctuating visibility, crucial for landing or takeoff. Clear skies, clear minds, the enduring importance of visibility in aviation. From fog-shrouded landscapes to dust storms, visibility is the lifeblood of safe aviation. Early aviators navigated by sight, while modern aircraft rely on sophisticated instruments. We've explored the science behind visibility and how water droplets and particles can transform a clear day. Different types of fog have unique implications for flight safety. Dust storms can halt transportation and test pilots. Instruments like transmissometers provide critical visibility data. Visibility is about awareness and understanding the environment. Even with technology, we are at the mercy of nature. Clear communication ensures the safety of all who fly. Appreciate the clarity of the air and the sharpness of the horizon. It's a testament to the vigilance and commitment to safety in aviation.